Hi, I'm Rick from arcadetestprep.com, and we have some SAT specific math problems. Feel free to print out this PDF and try them on your own or follow along as we cover these. Number one, here's an equation. What is the value of this expression? That is a clue. Anytime they ask you for some unusual expression, they're telling you it's going to be easier and faster to get that directly, not to get x individually. So always take the clue. How do we do this? We want to make it look like the answer. What might we do to that first equation to get an x squared involved? Well, if you divide everything by 3, that'll get the x squared term. And we just go with it because these problems always end faster than they might seem. So notice by dividing by 3, it just so happened to also give us the minus 7x. So now there's just one more step, which is to move the 6 over. And that's why the answer is 6. That took 2 steps, whereas to get x, it takes like 10. It's a whole mess. So always look for those clues and find those expressions directly. Number 2, here's an equation. R and t are constants. What's the value of RT? First thing to notice is you have one equation for 3 unknowns, which means you can't solve with math. There's not enough info. And so this means at some point we are going to be comparing like terms. To clear out the fractions, we can times both sides by x minus 2, x plus 6. That'll make the right side nice and easy. You can just write the numerator, the rx plus t. On the left, the first term, the x minus 2 will cancel. In the second term, the x plus 6 will cancel. And then we want to distribute, combine like terms. We get 7x plus 18 minus 8. So plus 10 equals rx plus t. And then we compare our like terms. The 7 is where the r is, so r is 7. The 10 is where the t is, so t is 10. So RT would be 70. Last step is to multiply them together for some reason. So always be looking to compare like terms if there are too many unknowns. Number 3, here's the function. When does f of k equal 4k? You can either plug in the k's or you can just solve it with the x's. We could express f of k as 48 minus 2k. They tell us it's 4k, so we could set those equal. Easiest enough to solve for the positive value first, so we can just drop the bars and solve it. And then we add the 2k over. 48 equals 6k, divide by 6. K is 8. There is another solution when we flip the sign, but we don't need to. 4 is exponent rules. You don't use logs ever on the test. It's really just getting a common base. So we get, on the left side, we want to just write it as b to the something. When we multiply, we add the exponents. I would just throw them all in the calculator and then have the calculator turn it into a fraction. So you end up that you get b to the 19 over 6 equals b to the a, which means a is 19 over 6. 5 is similar. We want to rewrite the left-hand side as x to some power. Fractional exponents can be created from roots. What's up high stays up high. The root becomes the denominator. When we divide, we subtract. So it becomes x to the negative 11 over 6 equals x to the a over b. That's why a over b is negative 11 over 6. And finally, number 6. When they ask, what can you conclude from a study or a survey or a poll, the answer is always not much. You want to put a very neutral answer. You don't want to say anything definitive. So we're surveying the town. 300 residents were selected at random. 84% say they are satisfied with the mayor's performance on economic matters. Based on the info, which of the following statements must be true? That must is a very important word. Lots of things could be true, but what must be true? Not much. And so we'll go through the Roman numerals here. Number 1, of all the town, 84% say they are satisfied. Possibly. Maybe this is a big enough sample. Maybe it's very representative of the town, but it doesn't have to be. Maybe the town had 10 million people in it, and it was a rainy day when they asked the people what they thought. So the data could be skewed. Nothing has to be true. Number 2, if you picked another 300 people, 84% would say they're satisfied. Maybe. But if we know how statistics works, there tends to be variability. The odds that it's exactly 84% on another day are not that good, I would say. But that definitely doesn't have to be true. So the answer is nothing. Nothing has to be true. Send an email if you have any questions. If you want to sign up for tutoring, we are still accepting students. Check our other YouTube videos, like the video, and subscribe if you liked it. And if you want to see more content like this, and good luck.